This section of the training is going to be looking at how to get started with your open SPR experiments. Here is a list of recommended steps to consider when setting up and performing a binding experiment. We will be going through and reviewing each of these steps in detail, but first we'll look at sample considerations for your binding system. One of the first things to do when planning an open SPR experiment is a literature background search on your binding partners. This would include looking for any past binding kinetics data, which could provide useful information on the potential binding affinity and sample conditions for your experiment. Factors such as molecular weights, tags on the molecules, isoelectric points, and additives provided in stock solutions can help determine which binding partner should be used as the ligand and which will be used as the analyte. Next, you'll have to determine the conditions that are necessary for the required binding interaction to occur. And lastly, you want to ensure that your samples have been purified and are homogeneous. The next thing to consider is the sensor chemistry for the application that you're going to be analyzing. So the one requirement to perform SPR interaction analysis will be to immobilize one of your binding partners onto the sensor surface. Here I have a picture of one of our sensors, and this consists of a glass slide, with the red spot in the center being our nano gold particles. Now, as mentioned earlier, these nano gold particles are going to be performing all of the detection for us. Now, in order to immobilize your biomolecule, we offer a wide range of surface chemistries to make this as easy and seamless as possible. So when you're starting out with a new binding system, you'll need to decide which sensor chemistry will work best for your samples. Now, if your biomolecule contains a tag, for example, a histidine tag, a GST tag, or a biotin tag, you can take advantage of this and immobilize them onto the surface via these tags using one of our capture coupling techniques. Now, if you're working with a biomolecule such as a protein without a tag, you can take advantage of a direct coupling technique. The most common one we have is our carboxyl sensor surface, which uses an EDC NHS amine coupling technique that will covalently couple any free amine groups to the sensor surface. Now, if you're working with a biomolecule that needs to be in a hydrophobic environment or liposomes, you can take advantage of one of our hydrophobic coupling techniques. Now, for each of the different sensor chemistries, we have a respective sensor chip tech guide which will walk you through the procedure for using each chemistry. Now, once the ligand has been covalently immobilized, it can no longer be removed from the sensor surface. Thus, covalent capture sensors can only immobilize a ligand once. Now, ligands that have been immobilized via capture coupling sensors can sometimes have their ligands removed and the sensor reused to immobilize a new ligand. However, this cannot be done with the biotin-streptavidin interaction, because this is essentially an irreversible interaction. Now, a sensor may be reused. However, this is dependent on the sensor handling, storage, and ligand stability. And it is recommended to test a reused sensor with a previously tested binding interaction to ensure that the sensor is fully active and has the same binding capabilities. Now, it is recommended that a new sensor should be used for publication quality results. Now, once you have your sensor chemistry chosen, the next thing you'll have to do is focus on your buffer and sample preparation, because the quality of sample preparation will be key for obtaining accurate binding kinetics. So first, you'll want to ensure that your running buffer is properly pH. You want it to be filtered, most commonly using a 0.2 micron filter, and this is just to remove any aggregates or dust which will prevent them from accumulating within the tubing of the instrument. And you want your running buffer degassed, which will prevent any accumulation of microbubbles within the instrument. And if you're using some unstable additives, you'll want to prepare a new buffer every day. Now, the most important thing to remember is that you need your analyte sample buffer to match the running buffer as closely as possible to avoid any background refractive index differences. So this means that you want to either directly dissolve or dilute your sample with your running buffer. because if the analyte sample buffer and running buffer do not match, you will see this mismatch appear in your data as a false positive shift. And I'll show you an example of that a little later on in the training.